Hey guys, welcome back to TechSav Live. Today I'll be talking about what a CPU is and how exactly it works. CPUs work very closely with the RAM, so if you haven't watched my video where I explain what RAM is and how it works, I highly suggest you go watch that one. But for today we'll be talking about CPUs. They also have an internal type of memory called cache, but I won't be touching on that today for the sake of simplicity. Now back to this video's context, what RAM stores are mostly instructions, and these instructions are used by the CPU when a certain process needs to be carried out, such as instructions for how to do a certain calculation or how to display text on a screen. And I'll be explaining how that works today. These pre-stored instructions ensure that the user has a consistent experience and that all programs always work as they're expected to work. So what the CPU does is it executes these instructions. So basically the RAM stores the instructions, the CPU executes these instructions, and whenever an instruction is executed, most of the time it'll require more information from the memory, because say the instruction is to put a title at the top of a website, the CPU would need more information such as the font size, how many pixels each letter is going to take up, where the top of the screen is, what color the font should be. All those types of information would be needed for a process like displaying a title. So the CPU requests that from the RAM and the RAM sends it back as per request. So on a very basic level, this is what a cycle is. Each cycle, the CPU requests information, does a calculation, and outputs information or requests more information to continue the calculation. Instead of always fetching, the CPU can also write new information to the memory, such as the result of a calculation. So especially when a certain calculation needs to be done over and over, in order to optimize that process, instead of having to redo the calculation each time, the CPU can actually write the value to memory. So for example, if the CPU needs to display a title at the center of a page, the CPU needs to figure out where the center of the page is, how many pixels that's into the page. So each time that calculation needs to be done, instead of doing that calculation, the CPU could just request that already calculated data from where it stored it in the memory before. This helps save a lot of time on calculation and enables the CPU to spend its resources on other more important calculations. Please note, most of the instructions I just listed are usually done on a software level by the website or the browser. I just use those examples to kind of clarify what exactly the CPU does in concept. So it does all the calculations, but it doesn't actually store anything. It's just the brain of the computer. It's not like the motherboard, how it's a communication center. It's more of a calculator for the computer. So in order to wrap up that explanation, a CPU runs in cycles. Each cycle, it requests data, does a calculation, and either requests more data or outputs a value and writes that value into memory forever. So basically there's always an in and an outflow of a CPU. Data in, calculation, data out. Now the CPU connects to the motherboard via this socket. In this case it's an AM4 socket because I'll be installing an AMD processor, and because of how fragile those pins are on the bottom of the AMD processor, I'll have to be very careful because once they bend, the processor is pretty much useless. And basically you just have to line the CPU up with the bracket correctly, and there's usually a triangle on the motherboard and the CPU to make this easier to find. Now there are different types of CPUs with different kind of specs. For example, one spec would be the clock speed. The clock speed is the frequency of how fast it can run each cycle. So for example, those cycles I talked about earlier, the clock speed is the frequency at which it can run those cycles in a particular time frame. There's also an amount of cores, so a CPU can have anywhere between 2 and 64 cores, which determines how many processes it can do simultaneously. This is called parallel processing. Which CPU you need, it largely depends on what your use case is and how often you're going to use it. So in terms of Intel, i3 or i5 are better for more mild tasks like web browsing, using Office apps like Word and Excel, or multitasking in general. But if you want to do gaming or video editing or even 3D rendering, I would suggest going towards the i7 and i9 line of processors. Keep in mind that the generation of the CPU also matters quite a lot, so in 2022 I wouldn't recommend buying anything older than a 10th gen processor because that wouldn't work very well with more modern programs. For example, a 10th gen i3 would actually perform better today than a 5th gen i9. So just keep that in mind when looking for a processor or looking for a computer and looking at what processor it has. When you're buying AMD, it's pretty much the same thing. The the lines are just a little more blurred. So the Ryzen 3 and Ryzen 5 series are used for mild cases like web browsing, mild gaming even, multitasking using Office apps, and then the Ryzen 7 series would be better suited for gaming, 3D rendering, and such and such. AMD also has a series called the Threadripper series, and the Threadrippers actually have up to 64 cores, which is very few people are going to need that, but I would definitely suggest doing your research and finding out what's available in your region and what exactly you need for your use case. Are you video editing, are you gaming, or are you just going to be web browsing? Pro tip, if you live in Australia, I highly recommend having a look at UMart or PCCG. They're the two, they're online stores, and they usually have a pretty broad range of products. Thanks for watching, guys. Please hit that red button and stick around for the next one.